So you're scrolling through Reddit and all of a sudden you see a mind-blowing example of what AI can do. Maybe you saw what DALL-E 2 is doing when it comes to image generation, or you might have seen what GPT-3 was doing for text generation. Well, how exactly is it that you get started? Well, it all starts with deep learning. And in this video, we're going to be focused on what you need to do in terms of getting set up and started. So this includes what do you need to install, how do you need to install it, as well as going through an end-to-end image classification example towards the end of this tutorial. Ready to do it? Let's get to it. What's happening, guys? My name is Nicholas Renat, and in this tutorial we are going to be focused on deep learning basics. Now, I've just gone and taken a little bit of a risk and uninstalled everything that I use in my day-to-day life when it comes to deep learning. But I really wanted to show you what you need to do in order to get started from scratch. Like, we're talking bare bones, nothing pre-installed. We're gonna go from the ground up so that you can follow along if you wanna start your journey yourself. So first things first, what we're going to do is install the environment that we're going to need. So we're going to do this by installing Anaconda, and Anaconda is going to come pre-packaged with a version of Python that we can use. We're then also going to take a look at installing CUDA and CUDNN. So this is going to allow us to perform GPU acceleration, but if you don't have a GPU, that's perfectly fine. You can still keep going with this. I'm also going to show you the flow that I have when it comes to setting up environments and getting them up and running with Jupyter, but we'll talk about that a little bit more later. And last but not least, right towards the end, I'm actually going to step you through an entire deep learning workflow so you can see how it actually works and how to give it a go. Ready to do it? Let's get to it. Hey Nick, you do deep learning, right? Is Lewis Hamilton the greatest driver of all time? Yeah, I dabbled. Got it. Want to show me how to set up my computer for it? Sure. First thing we need to do is install Anaconda, Python, and Jupyter. All right, let's kick it off. Alrighty, so deep learning basics. So this entire tutorial is going to be very much focused on getting you up and running with at least one deep learning use case. Now, rather than starting with all the installers, I wanted to show you what the end goal is. So the goal is to be able to run this entire image classification pipeline, which I've pre-written, which we're going to go into way more detail in an upcoming tutorial. But the goal is to get your computer up and running so that you can go and run through this to be able to perform or build a deep learning model which performs image classification. So you can see all of the deep learning layers there. Now, I'm going to show you how to do this from scratch and how to do it in a good way that's just going to make your life a whole bunch easier. So we're also going to leverage this code a little bit later on, but we are going to go completely from scratch. So if you are just starting out, this is going to be the tutorial for you because it's going to go all the way from the ground up. Okay. So the first thing that we need to do is recognize that this is currently inside of a Jupyter notebook. So the fact that it's got this extension here, so .ipynb stands for IPython notebook. So we can run that inside of two different types of servers, either a Jupyter notebook server or a Jupyter lab server. So what we actually need to do is get that up and running. Now, if we take a look at our to-do list, step one is exactly that. So we are going to be installing Python and Jupyter using Anaconda. So Anaconda is a big package repository that contains everything that you need in terms of getting started with data science, deep learning, machine learning, all that good stuff. So we can actually just go to this link here, and I'll make this entire to-do list available through GitHub as well. So I'll include that in the link below. So we are going to go to https://www.anaconda.com/products/distribution. So we can go to this link, and that is going to allow us to get Anaconda. Now, the link may have changed when you do finally watch this tutorial, but if you just type in Anaconda Python, you should get to the same link. So you can see it's going to Anaconda distro there. Now, first thing to note is that this is going to install or download this particular installer. So you can see it says for Windows, Python 3.9, and it's a 64-bit graphical installer. It's about 510 megabytes in size. By default, it should pick up the operating system that you're working on. So mine's picked up for Windows. If you're running on Mac, then you're going to want to go to the Mac installer. If you're running on Linux, you can also go to the Linux installer. Now, even though it is installing using Python 3.9, you can, inside of Anaconda, switch over the Python version. So if you've got a really specific requirement, fret not, you can solve that. For now, what we're going to go on ahead and do is download Anaconda. And you can see that that is going to go on ahead and download there. Now, I've already gone and downloaded this, so I can go and kill it. So you can see it's downloading. Let me zoom in on that so you can see it. It's downloading a file called Anaconda 3-2021.1. So I've already gone and downloaded that particular file. But that is the first thing that we need to go on ahead and download. So once we've got that downloaded, we can actually go and install it. So if I go over here, so you can see I've got that file there. So Anaconda 3-2021-11 Windows x86 64. So this is going to install Python 3.9 on a 64-bit machine. Now, by default, it should pick up the relevant version, but as soon as you've got that downloaded, all you need to do is double click on the installer, hit next, hit I agree. And then in my particular case, I'm going to install it for all my users. So if I log in as a guest user or a different user, I can still use Anaconda. So we're going to hit all users, hit next. Then this should go black just for a second. Okay, so we're back. So that's just the security pop-up, perfectly fine. And then you can see that we've got a destination folder here. So you can see it's going into C, program data, Anaconda 3. If you've got a previous installation, it might still have a folder there. So if we go next, okay, that looks all right. So it's going to go into C drive, program data for / Anaconda 3. Feel free to name that or put it into a different location if you want to. This is the default, tends to work fine. So we're going to hit next. And then this is really critical. So this tab over here allows you to add Anaconda 3 to your path environment variable, which means you're going to be able to launch it from your command line. Makes your life a ton easier. So make sure you tick this, even though it's red. So in spite of the fact it says not recommended, perfectly fine. Make sure you tick that flag. And then hit install. And that's going to go on ahead and install Anaconda for you. So let's give that a sec. And then we should be good to go.
5 minutes later.
Alrighty, that is Anaconda now installed. So you can see it says it has completed. So we're looking good in that particular space. No, I don't want quick assistant. Cool, so we're looking good. We can hit next and then next again, and then we don't need to launch either of these. So you can deselect Anaconda Individual Edition Tutorial and deselect Getting Started with Anaconda and hit finish. Cool. All right, so that is the first thing now done. So if we type in done, we are done with that first task. So before we jump back on over to our client, let's actually take a look at what we can now do. So previously I had no Python environment installed on my computer, but now what I can do, because I've gone and installed Anaconda, I can actually launch a Jupyter Notebook server or a Jupyter Lab server. So if I want to type in or launch Jupyter, I can type in Jupyter Notebook. And this will actually launch a server. It's going to ask me how I want to open this file. I'm going to just select my default browser, so Google Chrome. And this is open on another screen. So if I bring that over, this is what Jupyter Server looks like. Now, the biggest thing to note is that we typically use this to open up Jupyter Notebook. So if I wanted to go and open up an image classification notebook, I could definitely go and do that. So this is just one that I've currently got on my desktop, but I could go and open up one that I've got for where are some of my YouTube ones? So for example, web game. So I've got one that I was building for a Dino AI tutorial. Now, ignore this for now. I'm going to show you how to solve this in a second. Just know that we can actually start leveraging this Jupyter Notebook server to do stuff. But in terms of what we do with it, we'll come back to that in a second. Now, if it doesn't open up by default, when you do run the Jupyter Notebook command, you're actually going to have this link generated here. So you can just copy this link. So you can see it's saying I'm serving notebooks from local directory. Jupyter Notebook 6.4.5 is running at this link. So if we copy that, we can actually go back to our browser, paste that in. You can see we're back to the same spot. Now we can also stop that server. So all we need to do is hit Control C and that's going to stop it. So you can see it's shut it down. So we've got no terminals running. Now, I also mentioned that we can start up Jupyter Lab. So Jupyter Lab is another way that we can open up Jupyter Notebooks and tends to be the way that I use it because I just find it looks a little bit nicer. We can go to dark mode as well. So we can type in Jupyter Lab at the command prompt and it is JUPYTERLAB. That's how we start up either Jupyter Notebook or Jupyter Lab. And again, so if I wanted to go into my Dino AI tutorial, I could go and do that. right? So I've got a web game environment. I can open up this notebook now. And again, we'll just ignore that for now. But you can see that this is how we can actually leverage a notebook. Now, if we wanted to, we could actually create a new notebook, and let me show you how to do that. So all you need to do is hit this blue button over here, and well, that's going to open up the launcher. And then from there, what we can do is actually start up a notebook. So we can just choose what kernel we want to actually leverage. But again, more on that in a second. So if we open up that kernel, we can actually write Python inside of these cells. So I can type in print, hello world. Right? And this is actually running our output. So you can see that this is my Python code. This is the output from that particular line of code. Let's zoom in on that so you can see it a little bit better. Now we could do a whole bunch of stuff if I wanted to write a loop. So for x in range 10. So again, it's just running Python. I could print x. Pretty cool, right? Now, these cells can be a bunch of different types of cells. So say, for example, you can see I've got this current cell set to code. I could convert that to Markdown, and this is going to operate as Markdown rather than a code cell. Now we can navigate through these cells. Let's say, for example, we wanted to convert that cell back to code. All you need to do is hit Y on your keyboard, and it's going to convert it back to code. If I wanted to convert it to Markdown, I can hit M. It's going to convert it to Markdown. And this is because the cell is selected but not currently active. So you can see that it's blue. As soon as I step into that, if I hit M, I'm actually going to be writing code. So what I need to do is hit escape. And that means that I've currently got it selected, but I'm not coding inside of it. And I can toggle, right? MY, 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 so on and so forth. Can hit Shift Enter to actually run that. So you can see I'm running these lines of code. If I wanted to add a cell above, I can just hit A. If I wanted to delete a cell, I hit DD on my keyboard. So these are just a couple of shortcuts. Now, there are a whole bunch of additional shortcuts. I can never remember where they are. All right, they're over here. So there's a Jupyter reference. Does that actually give us all our shortcuts? I can never remember where these actually are. But there's a whole bunch of shortcuts that you've actually got available through here, and a whole bunch of documentation for how to actually use Jupyter. I tend to use Shift Enter to actually run a cell, A to add a cell, D to delete a cell. Now, if you wanted to delete the output from a particular cell, you can also go to Edit, and you can go to, where is it? Clear output. So that will get rid of the output of a cell, right? So you can see it's deleted the hello world. If I step out of this one and do it on this one, again, I'm clearing the output. Okay, that is Jupyter in a bit of a nutshell. Let's jump back on over to our client and have a quick chat to see what's next. So that's now done. Nice. What's next? Well, we're going to create an environment for our deep learning project. Why? Didn't we just set up Python? Isn't that enough? Getting Python up and running is a great first step, but having an environment is going to make your life a billion times simpler, particularly when it comes to working with multiple projects. Think of an environment as a little world for your project. Everything it needs to live, breathe, and survive is going to be encapsulated inside of it. This means that all of the extra modules and dependencies are going to be there when you need them. It also means that there's going to be less conflict with other stuff that you might have on your computer. Got it. Does it work with Jupyter as well? Sure does. I'll show you how to get them synced up with your Jupyter server as well. Alrighty, and we're back. So now what we're on to is actually creating some environments. Now you would have seen previously when I was opening up this notebook, I was getting this weird pop-up saying there's no kernel, or there's no kernel attached to this particular notebook. And that is actually referring to the environment that our particular Jupyter notebook is actually working with. Now, before we get to that, let's actually get the proper notebook that we're going to be working with. So remember I said that we were going to be going on and working with this image classification notebook that I had up on the screen. Now, you might be super familiar with this. So if you're experienced and you've worked with Git, you can probably skip this step. But for those of you that are completely new to this, I wanted to give you a little bit of a background. So GitHub is a place where you can store your code, your data, your different models, and it's a really popular way for sharing these with other people around the world. Now, I tend to upload virtually all of my code that I write for YouTube inside of GitHub. So if ever you wanted to, or you saw a tutorial and you're like, Nick, I just want to try out the code, I don't want to go and do it step by step, normally they're all available here. Pretty much 99% of the time. That other 1% is me generally forgetting. So we've got this image classification repository that we've got here. And this has got data, it's got models, it's got a git ignore file, it's got some pictures, and it's got that Jupyter notebook that I showed briefly. Now, let's say that we actually wanted to start leveraging this. Well, the first thing that we need to do is we actually need to go on ahead and install Git. Now, by default, this is going to be available on a Mac machine, but if you're on a Windows machine, you actually need to go on ahead and set it up. So, first thing that we're going to go on ahead and do is set this up for our Windows machine. So we can actually go to this link, so Git for Windows. So we can go to https://git-scm.com. And what we can do is download Git, right? So over here, you can see we can go and download that particular source, and we can hit download for Windows. And we are going to choose the 64-bit Git for Windows setup. And that's going to go on ahead and download. Now, again, I've already gone and pre-downloaded this because my internet is slow as hell. So let's go on over to that. So I've got Git over here. So Git 2.36.0-64-bit. So you can see that over there. So what we're going to do is double click that and install Git. And again, we can just hit next, next. So it looks like we've already got it installed. So we're going to install it again. Hit next, hit next, hit next. Yeah, you can pretty much just leave all of these by default. So we're going to leave Git on the command line. So we can hit next there. Leave that. Next, next. There's a lot of these, right? Cool. Next. Yep, next. Next. And then, yeah, next. All right, cool. So that's going to go on ahead and install. So that will allow us to be able to leverage Git. So let's let that install and we should be able to use it in a second. Coolio, that is Git now installed. So again, we can hit finish. It's going to open the old release notes. We don't really need to delve too much on that. So let's take a look. So we've now gone and installed Git. What we actually want to go on ahead and do is get that repository from GitHub. So in order to do that, we are going to open up a new command prompt, or we can actually stop our existing one that we had from Jupyter's notebook, Jupyter Lab. We can type in CLS on Windows to clear that, and we are going to clone this down. So there's a really simple command to be able to clone this from GitHub onto our local machine. So, and that command is git clone. So I'm going to copy this link. And over here, I'm going to open up. So we're currently in our D drive. You can see that there. What I'm going to do is I'm going to clone that repository. So I can type in git clone. And you can see there's no folder called image classification here yet. So if I type in git clone and then the link to that GitHub repo, and it looks like it's saying Git is not recognized. Let's open up a new command prompt because remember we installed it. Now we still had the old command prompt installed. So if you've gone and installed it and it's not showing up, that's probably actually good that you've seen that. That's fine. Close down your command prompt, open up a new one. So we'll try it again. So git clone, paste that link, and you can see it's working now. So the reason that we had that little pop-up is we'd installed it, but we hadn't reopened up our command prompt. So it wouldn't have actually known what that git command is. But you can see it is successfully cloning down. And what you can see there is that we've actually got that repository cloning. Oh, that's gone crazy. You can see that we've got image classification over here, and it's starting to clone down all the stuff that's inside of that GitHub repository. So in a second, what you shall see is all of this stuff available all over here. So again, let's give that a second and let it finish cloning, and then we'll be able to create our environment for it.
A little longer than a few minutes later.
Cool, that is now cloned, and you can see that we've got a data folder, which has a bunch of images of happy people. We've got a sad folder, which has a bunch of images of sad people, because our deep learning model is going to classify as people being sad or happy. And we've got a folder called models, and we've got this H5 file. We'll talk about that a little bit later. We've got a git ignore file, which you can just ignore for now. We've also got a couple of images. So these are just going to be testing images. And we've got our Jupyter Notebook file. So again, remember, how do we start up our Jupyter Notebook server? We can either type in Jupyter Notebook or Jupyter Lab. So we're going to use Jupyter Lab. So I can type in Jupyter Lab. And that's opened up. We can close these old ones. Cool. So again, we're inside of Jupyter Lab. Now we are going to go inside of our image classification folder, which we just cloned down. And we can open up this Jupyter Notebook. Now, we've got an error. How are we actually going to solve this? So I actually wrote this Jupyter Notebook probably 2 or 3 days ago. And when I was doing that, I was actually coding it up inside of Python 3.7. Now, this particular error is telling me that we can't actually go ahead because this notebook is attached to a Jupyter Notebook environment, which was authored in Python 3.7. But that's perfectly fine. All we need to do is change the environment that this particular notebook is running on. Now, inside of Jupyter, environments are referred to as kernels. So all we need to do is jump on over to here, which you can see it says kernel. And if we go to change kernel, let's move this out of the way. We can go to, let's say, for example, let's go to a generic kernel. So right now, a generic kernel is just Python 3 IPy kernel. So we can select that and hit select. And then if I hit OK, that error is now gone. Now over here, you'll see that our Jupyter Notebook is now running off our Python 3 environment or Python 3 kernel. But this can get a little bit messy because we're going to go and install TensorFlow, OpenCV, and a whole bunch of other stuff, which may start conflicting with the other environments or with the other projects that may be using that particular environment. So let's say, for example, one project needs TensorFlow 2.4.1, which is a really specific version. And we're going to go on ahead and overwrite this. So right now, this would go and, well, assuming there was no other TensorFlow installation, this would go and install the latest version of TensorFlow, which might screw up our other projects. This is where environments come in. So we can isolate all the stuff that we're going to need for this particular Jupyter Notebook or this particular project. Now, if we go to kernel and hit change kernel, you can actually see all of the different kernels or environments that are attached to our particular Jupyter Notebook. So we've got one called Deep Learning, DS Course, iTrack, FinRL, Learning. That's our generic one. We've got one called Started, one called SuperRes, and one called Toxic. Now, we actually want to go and create one for our image classification project because right now we don't actually have one that we can associate to our notebook. Sometimes what actually happens is people will go and create an environment, then go and run this notebook and be like, Nick, it's not working. I'm installing stuff and the notebook's still not picking it up. Well, that's because we need to create the environment, but then associate it to Jupyter so we can actually pick it up. Now, I'm going to actually walk you through this because I do this every single day and it's quite possibly one of the most important skills that I've picked up in terms of being productive when it comes to machine learning, deep learning, and all of that good stuff. Cool. So what are we going to do? Let's quickly take a look at our to-do list. So we've now gone and installed Git, so we're good with that. We are now going to go through our environment creation workflow, which are these steps over here. So this should be lowercase. Let's go on ahead and do it. So I'm going to hit cancel and we are just going to stop Jupyter for now. So we're going to go back to our command prompt and we're going to clear it. So on Windows, I can type in CLS and let's go on ahead and create an environment. The first thing that we want to do is we want to create the environment inside of the same folder that we are going to be doing all of our work in and just keep stuff a little bit nicer. I know I'm a little bit OCD, but that's just me. So I'm going to type in dir. So right now we've got a folder called image classification. So dir allows us to see all of the folders that we've currently got. So we are going to go into that folder first up. So I can type in cd image classification. Let's hit CLS so we can clear all of that. And then we're going to create our virtual environment in here. So the command to create a virtual environment is python -m venv and then the name of the environment. So I'm going to call it image classification. And that's pretty much it. So python -m venv image classification. So if I go and run this now, and this is for Windows. So if you do need a Mac equivalent or a Linux equivalent, just type in venv python and you'll be able to get the documentation up here. So over here, you can see that we are creating it as follows. So what you can see there. Now, in terms of activating it, we'll come back to that in a second. But for now, just know to create a virtual environment, it's python -m venv image classification. So if I go and run this, all things holding equal, it should create a image classification virtual environment. So again, we've got no errors there. Now, inside of our image classification folder, we actually have a virtual environment called image classification. This might get, we are inside, it should be okay. All right, so what we're going to do now is we are going to go on ahead and activate this particular environment because right now we're not actually using it, right? So we are going to activate it. So if I type in /image classification, so whatever the name of the virtual environment is, then /scripts, then /activate, this is going to activate my environment. And this is specific for a Windows machine. For a Mac, it's slightly different. And I'll show you where to get that particular command. If I go and run this, you can see that we are now inside of that virtual environment. So we've got a set of parentheses with the name of our virtual environment over here. So our virtual environment is called image classification. Our folder that we are currently working in is called image classification. We could call this whatever we wanted to. It could be called Deep Learning Project 1, for example. In our particular case, that's what we've called it. If you are running this on a Mac, these are the commands that you're going to need. So typically you'll be running it on bash. So the command will be source, the name of the virtual environment, /bin/activate. So that's that over there. Can you see that? So source, the name of your environment. So don't include the arrows. Get rid of that. What you want to do is put in the name of your environment, /bin/activate. And that should effectively do that. The one that we just ran is this over here. So we would be running // the name of our environment, scripts, activate, and we drop the bat. You don't need that. Okay, so we have gone and successfully activated our environment. Let me zoom out. Now, what's the next thing that we need to do? So we've activated it, but now we actually need to go and attach it to our Jupyter notebook. So if we go and type in Jupyter Lab, and this is where a lot of people go wrong, and they'll go and create the virtual environment, then open up Jupyter Lab, and just because they've activated or started up Jupyter Lab inside of the activated environment doesn't mean anything, right? So if I went and installed a random library over here, it is still running inside of that default kernel. So if you've ever installed something inside a Jupyter notebook and then you're like, Nick, it's not picking it up, this is why. Because even though you've activated it, you haven't associated it to Jupyter. That's why you're getting those problems. But I'm going to show you how to do that. So not an issue. So we are going to stop our Jupyter Lab server and we need to go and install it. So to install it, first what we need to do is install a library called ipykernel. So let me show you where this is at inside of our to-do list. So we've now gone and created our virtual environment. So this is done. So remember to create it, it's python-m venv, and then the name of your virtual environment. This one here says image classification or image class. Then you need to activate it. So we've done that as well. And to activate it, it's // the name of your virtual environment, /scripts, /activate. Again, it's slightly different for Mac. I'll link to the documentation in the description below. Then we need to go on ahead and install ipykernel. So let's actually do that. So I can type in pip. Let's clear this to keep it a little bit neater. Pip install ipykernel. And this is going to install it inside of our virtual environment that we've just gone and created. And ipykernel allows us to attach a virtual environment to the Jupyter Notebook kernel that we actually want to go on ahead and run. And that's what does that linking. So that means when we install stuff inside of our virtual environment, it's going to be showing up inside of our Jupyter Notebook kernel. So let's give that a second to finish running and then we can go, oh, well, it's done now. So it looks like we got a warning. You're using pip version 21.2.3, however version, whatever. That's just telling us there's a newer version of pip. You can ignore that for now. So we now have ipykernel available inside of our virtual environment. Now we can verify this by running pip list. And we should see ipykernel, so we can see that there. So pip list shows you all of the different libraries that you've got available inside of your environment. Now, because we've got a virtual environment activated, this is showing us the stuff that's available inside of our virtual environment. Okay, but now what we need to do is actually go on ahead and use that. So to use it, we can type in python-m ipykernel install --name and then the name of our virtual environment. So --name equals, and then we are going to name it image classification. So the full line is python-m ipykernel install --name equals image classification. So if I go and run this now, you can see it's actually gone and installed it. It says installed kernel spec image classification in blah, 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 blah. Now, if we actually wanted to go and check what all of the different environments or kernels that we've got available inside of Jupyter, we can run Jupyter kernel spec list. So this should actually show us all of the different kernels available. So Jupyter kernel spec list shows us the different kernels that we've got available. So you can see we've got our default one, which is Python 3. We've got deep learning, DS course, iTrack, FinRL, image classification, which is the one that we just created. Learning, started, SuperRes, and toxic. Now, if we wanted to go and delete one, we could do that as well. So we could type in Jupyter kernel spec uninstall. then I think, what is it? Do you pass name? No, you just pass in the name of the kernel. So you don't need to actually name it. So let's say, for example, we wanted to get rid of our image classification one. Let's do that. So Jupyter kernel spec uninstall image classification. It's going to ask us whether or not we want to delete it or uninstall it. We can hit yes. It's now removed. So if we again go and type in Jupyter kernel spec list, image classification is no longer there. Now, if we go, let's go on ahead and install it again. So again, Python-m, and it's good practice, guys. Python-m, what is it? IPyKernel install --name equals image classification. All right, so that's our line to go on ahead and install it. Let's install. Cool, so no errors. We can verify. So Jupyter kernel spec list. We've got it there. All right, now if we go and run Jupyter Lab, check this magic out, guys. If we go and open it up, and if we go to kernel, change kernel, we are going to set it to our virtual environment. So if we go, you can see that we've got image classification now available. Magic, right? But this is great. So we can now use this virtual environment inside of our Jupyter notebook, which means that if we go and install stuff inside of that virtual environment, we're going to pick it up inside of our Jupyter notebook. Cool. And again, we can hit save and that's going to save it. So if I go and write a new line, so remember A gives me a new cell. So let's type in print blah, blah, blah. You can see that we've got this circle here, this full circle. That means that our notebook is not saved. So if we want to save it, Control S, that saves it. Okay, let's go back to our to-do list and see how we're doing. So we've now gone and installed Git. We've now gone and created a virtual environment. We've now gone and activated it. We've installed IPyKernel. We've gone and attached or installed our virtual environment to our Jupyter notebook. And we've also gone and taken a look at how we can delete environments. So this is done. This is done, and this is done. So this entire task is now done. Let's jump back on over to our client and see how we're doing. So what's next? Well, now that we've got Jupyter and our environment set up, it's time to install a deep learning framework. Sweet, which one? Well, the choice is yours, but we're going to be working with Tensorflow and Keras. It's straightforward to work with and makes integration and deployment into apps and edge devices a ton easier. Nice, let's do it. Alrighty, cool. So we're back. So we've now gone and done steps 1 and 2. So install Python with Anaconda. We've gone and taken a look at environment creation and I've shown you my workflow. So that's actually what I do in real life every single day when I'm building deep learning stuff. Now, the good bit, the juicy bit, installing TensorFlow for deep learning. So there is a great guide on doing this over on the TensorFlow website. So let's go and take a look at that. This is available at https://tensorflow.org/install, and we are looking at the Windows version. If you wanted to take a look at the Mac version, you've got that available over here as well. Cool, Windows, Mac, Windows, Mac. All right, now, there are a couple of key things that we need to go on ahead and install when we are using, so we're going to be doing it with pip over here as well. Couple of key things that we actually need to go and use when it comes to getting TensorFlow up and running. So pay attention to this. So the system requirements. So if we're going to be, we need to be using Python 3.7 to 3.10. Python 3.10 supports TensorFlow 2.8 or later. So we are using Python 3.9. Remember when we went and installed Anaconda? Let's go back. We downloaded Python 3.9. So Python 3.9 requires TensorFlow 2.5 or later. That's fine. We'll download the latest when we go and run a pip install. We need pip. That's fine. It comes with Anaconda. You need to either be running Ubuntu, Mac OS, or Windows 7. Later. So again, we're going to be doing it with Windows. If you are installing on Windows, you need to install the Microsoft Visual C++ redistributable for Visual Studio 2015, 2017, and 2018. But that's fine. I'm going to show you how to do that as well. And if you're going to be using a CUDA-enabled machine, then you need to go and set up the CUDA bit. But we're going to come back to that a little bit later. So let's take a look at what we actually need to do here. So first up, what we're going to do is run a pip install, and then we're going to go on ahead and set up the Microsoft Visual C++ build tool. So we can actually do this side by side. So if we go over to here, I've actually got the commands inside of the notebook for you. So I'm going to go ahead and step out of that cell, delete our random print, delete that, delete that, delete that. And because we are inside of our virtual environment, inside of Jupyter, we can actually go on ahead and run this command. So !pip install TensorFlow, TensorFlow-GPU, OpenCV-Python, and Matplotlib. So this is going to, TensorFlow and TensorFlow-GPU are going to install TensorFlow into your virtual environment. So we can actually run Shift-Enter and kick that off. Now that will take a while because it's going to download all of TensorFlow, which is quite a large file. In the meantime, let's go on ahead and install the Microsoft Visual C++ redistributable. I've already got that bit installed because it takes a ton of time to download, but I'm going to show you exactly how to do it. So if we go to the links that are supported here, no, that's not the link that I wanted to give you. So there is an easier one. So if we go to over here, https://visualstudio.microsoft.com/downloads, what you need to do is download this bad boy. So over here, all you need to do is select community. So that is going to download Visual Studio 2022. And through that, what you need to do is install the desktop C++ dev tool. So I'm going to show you how to do this. So if we hit download here, that's going to download the downloader because there's a separate set of downloads. So we can open that up, hit yes. And in this particular case, we are going to hit continue. So that's going to download the full-blown installer. So we'll give that a sec. All right. Now, when it comes to installing, I've already got it installed. So there's a little bit of pain. Let's actually go and hit modify. Right. So when it comes to installing, what you're going to do is it'll open up to a screen that looks like this. What you're going to need to do is go to this bit here, which says desktop development with C++, and make sure you tick that. That is what is going to give you those build tools needed for TensorFlow. So tick that and then hit install. So I don't have anything new to install here because I've already got it ticked and installed. If you're doing it for the first time, it's going to open up to this screen. You need to select that. So desktop development with C++, then hit install. This is needed if you are installing on a Windows machine. Doesn't apply to a Mac. I don't think it applies to Linux machines either. That's just an important thing to note. You need to go through this process and install that, and you should be good to go. Once that's installed, you should have Visual Studio Community 2022. Is that supported? What does it say? We actually need 2019. So ideally, you want to be downloading 2019. Let's go back. So over here, we've got 2019. Let's actually find the 2019 Visual Studio. 2019. And 2019 is not appearing there. It's not available. So let's find it. Here we go. Older downloads. There we go. 2019. So you're going to be wanting this one. So Visual Studio 2019, hit download. And that is going to include those build tools as well. So then you can log in, do all those downloads, and remember, ensure that you're just double ticking that C++ development set. I think it might work with 2022. I don't know, maybe it hasn't been updated on the website, but in my particular case, it is working. It says 2019, so follow the steps, but I've used 2022. Still seems to work okay because it is leveraging the build tools, not Visual Studio itself. So remember, you need those desktop development tools with C++, and that is going to get you up and started. Cool. All right, so, TensorFlow is finished installing. Okay, so that happened reasonably quickly. All right, so in the meantime, while we were taking a look at Visual C++ build tools, this command over here is finished running. So our !pip install TensorFlow, TensorFlow-GPU, OpenCV-Python, and Matplotlib command is now done. So if we go and run pip list, let's go on ahead and take a look. Do we have TensorFlow there? Take a look at that. TensorFlow 2.8.0 and TensorFlow GPU 2.8.0. So that is looking well and good. Let's just jump back on over to our to-do list and see what else do we have to do. So we need to install TensorFlow for deep learning. We've gone through the pip install. We've gone through the Visual C++ build tools. So this step is now done. Now, if you wanted to stop here, you could, right? You don't actually need to go any further if you're not going to use a GPU. Because we can actually go and run this code right now, but this will not be picking up our GPU. So if I run this, So again, Shift Enter allows us to run ourselves. So this first line is importing TensorFlow. So import TensorFlow as TF, import OS. Right, so that's run successfully. This line over here, we'll probably go through that in more detail when we do the image classification deep dive, but it effectively allows or stops TensorFlow from taking up all of the VRAM on your GPU. Now, right now, really, really important. So I've gone and run this code, and this actually lists all the physical devices that you've got, and it filters it out based on what you pass through here. So this is listing out all of the GPUs that are available to TensorFlow, which you can see are none. And this is because we haven't actually configured this to be able to leverage our GPU as of yet. So if we go and run through this pipeline now, let's go through this relatively quickly. So again, I'm just running Shift Enter, and this is working through our pipeline. So this is the bit that I want you to get to. So over here, let's take a look. So you can see that by running TensorFlow without a GPU, it is taking 692 milliseconds per step. Let's just make a note of that. So 692 per step. So that's just a note that when we actually go and apply our GPU, we'll actually be able to see how much faster it's actually training. But right now, it looks like it's training. Our accuracy is going up. I'm going to delve into this in a little bit more detail towards the end. But just note that this will run without a GPU perfectly fine. You don't need a GPU if you want to get started with deep learning, but I want to show you how to do that. So what we're going to do is we're actually going to stop this cell running. So we can go up to here and hit stop. And you just got to hit it a bunch of times and we'll get this keyboard interrupt. But for now, we know that this pipeline can actually run without our GPU. But let's jump back on over to our client. Well, let's actually take a look at our to-do list first. That's done. We can jump back on over to our client. Let's do it. Nick, training seems a little bit slow. I've heard we can speed it up with a GPU. Is that right? Yep, if you've got a GPU, you're going to want to make use of that for deep learning. Right. I had to sell my entire Vax Doggo NFT portfolio to get one, but I've got one at last. Cool. Well, in order to get it set up, we need to install two key libraries. These are CUDA and CUDNN. Are those free? Sure, as long as you've got an NVIDIA GPU, you're going to be fine. What about if I don't have a GPU? Can I still do deep learning? Yeah, definitely. It'll be a little bit slower, particularly when it comes to computer vision and NLP tasks. Got it. Let's go.
Alrighty, and we're back. So what we did last time is what we've done successfully is we've installed Anaconda, we've installed Git, we've taken a look at our virtual environments, we've also installed TensorFlow. Now, the good bit. Setting up your GPU for computational acceleration. That sounds very fancy, but really it's just enabling your GPU for deep learning. Cool. Alrighty, so to do that, we need two key things. We need CUDA and we need CUDNN. Now, these versions are going to vary depending on which version of TensorFlow you've got installed. Now, I want to show you this in great detail because it can cause an absolute nightmare if you don't know how to do this. So, specific versions of TensorFlow map to specific versions of CUDA and CUDNN. If you don't have the right versions, it may not work. So even though you might have CUDA installed, it might not pick that up in TensorFlow and you might not get that speed boost. So let's actually take a look at the version of TensorFlow that we've got installed at the moment. So !pip list will give us that. So what version do we have? We have 2.8.0. Now, if we go to the TensorFlow site, so tensorflow.org, throat's getting a little dry, tensorflow.org/install/pip. And over to here, if you go to Windows, because we're running on a Windows machine, scroll on down. Over here, you can see it says tested build configurations. If you go to GPU, this master table gives you all of the different combinations that will work together. So we are currently running TensorFlow GPU 2.8. We have Python between these versions, so we're using Python 3.9. We've got the Visual C++ compiler, so you do need 2019. Really important thing to note, do 2019, don't do 2022 as of yet. The CUDA and CUDA CUDNN versions that we need are 8.1 and 11.2. So we need to ensure that we have a matching version of CUDA and CUDNN that matches with our TensorFlow GPU version. So let's go on ahead and go and find those. So if we go to our to-do list, CUDA is available through this link. So https://developer.nvidia.com/CUDA-toolkit. So if we copy this, jump on over here. This will allow us to download CUDA. So if you scroll on down, you can see we can download it. So I'm just going to hit download now. And if we hit we want Windows and we want the x86, what is that? The 64-bit version. And we can choose which version we want. So we want it for Windows 10. We want a local version. And in this particular case, it is going to be downloading CUDA 11.6. That is going to be a little too far ahead of our Windows version. So let's actually go back. So this might mean there's a newer version out. If we go to CUDA 11.2, you can see that we have now, so again, I've just plugged this into Google. So CUDA Toolkit 11.2.downloads, we can actually go and download it from this particular link. And because there will be continuously new versions of CUDA coming out, it's good to know how to go and find the version that you need. So going to my default link, which looks to have worked only a couple of days ago, looks like there's a new version of CUDA out. So if you just go to Google, search for CUDA 11.2, that will give you the right version, or ideally give you the right version. I'll show you how to look for it. So if we select Windows again, we are going to, for the 64-bit version, for Windows 10, we want the local version. Let's take a look. All right, this looks good. So you can see it says CUDA _ 11.2.0. That means that we are picking up the appropriate CUDA version. This will be the build number. The last bit will be which operating system it's going to run on, which is Windows 10 in my particular case. Now, what we can go on ahead and do is download that. And that is going to go on ahead and download. I've already downloaded this, so we don't need to wait for that. Let me show you the next thing that we need. So the next thing that we are going to need is CUDNN. So again, you need both of these to be able to run TensorFlow with GPU acceleration. So let's double check what version of CUDNN is available. So again, if you go to this link, so developer.nvidia.com/CUDNN, you will be able to download CUDNN. Key thing to note is that when you go to try to download this, you need to have an NVIDIA developer account. It's perfectly free. You just need to go and sign up. So if you go to download CUDNN, we should be able to download it. Wow, my internet is going hella slow. You also need to agree to this AI statement. Don't build any bad AI, guys. So again, we're going to agree to that. This is showing CUDA 8.4. Is that going to match? CUDA CUDNN 8.4. No good for our particular instance. So how do we find it? We just search CUDNN. What do we need? 8.1. 8.1 into Google, and we should be able to find it inside of the archive. So you can see that we've got an archive there. Let's open that. And we need an 8.1 version. So we've got this 8.1 version showing up over here, which says that it's going to run with CUDA 11.0, 11.1, and 11.2. So let's download that version. And we need to look for our particular environment. So we are going to be running it on Windows. We want it for, do we have a 64-bit version? Should be this is for Red Hat. Let's look. No. There's this version here. Maybe there's no others. Let's download that one. Cool. So that's going to download that. So let's take a look. All right, so in my particular case, well, that's how to go and find them. So again, if you can't find the appropriate version, jump into Google. More often than not, you'll have to go to the archive if it is not the latest one. All right, so we've got CUDA 11.2. Is that the version that we needed? 11.2 and CUDNN 8.1. So again, I've gone and downloaded these previously so that we can speed this up. So what do we have? So we've got CUDA 11.2, and I have, you can see that right there. Let me zoom in. So I've got CUDNN 11.2 Windows-x86 64 version 8.1.1.33. Is that the one that we were just downloading? Let's double check that. Let's see what we're downloading. Yeah, exactly the same as what we were downloading there. So again, let me zoom in on that. So CUDA 11.2 Windows x86 version 8.1.33. So again, you might just need to go to the CUDNN archive to be able to find the appropriate version, because look at how many have come up from after that. So that was released in Feb 26. There's a ton of new ones. Okay, but that is how to find the appropriate versions. Whatever you do, just make sure you download the versions that match the TensorFlow GPU version. Otherwise, you're going to have a bad time. Okay, so we've gone and downloaded those. Now what we need to do is install them. So for the CUDA installation, pretty straightforward. You just need to double click it. There's an installer. I've just gone and double clicked it. Just to install it wherever. So this is just the setup package. It's going to unpack it and then we should be able to install it.
5 minutes later.
Okay, that is successfully unpacked. It's going to do some system compatibility checks. And then we should be able to use this. Or set it up, install it. All right, so we need to accept the software agreement. So we're just going to hit agree and continue. We can just do the express install. Let me zoom in on this so you can see it. We're going to hit next. And again, this might change in terms of the look and feel. But again, for now, Tensorflow, you need CUDA and CUDNN for Windows. And for any GPU installation, you need it for Linux as well. So it's going to prepare the installation and then it should just kick it off. Let's give it a sec. All right, so this is installing. So we'll just let that run and install and then we'll be right back and I'll show you how to set up CUDNN.
A little longer than a few minutes later.
Okay, that is CUDA now installed. So we can hit next. We don't need to launch any of these. So we can deselect them and hit close. Okay, so now that CUDA is installed, what we need to do is go and install CUDNN. So this one's relatively straightforward. So you need to go back to where you've gone and installed CUDA. So in my particular case, it's my C drive. So I'm going to open that up in a new window. And what I need to do is go and find the CUDA installation. So mine is in program files. And then it should be NVIDIA GPU Computing Toolkit. So let me zoom in on that so you can see that there. And then you can see it says CUDA, pretty big. And we've got this version 11.2, which is what our TensorFlow version needs. Now, the CUDNN installation, normally it just comes zipped up. So I've gone and unzipped it already. Inside of here, you're going to have a folder called CUDA. And inside of that, you've got a folder called bin, include, and lib. Let me zoom in on that. Bin, include, lib. What you need to do is copy the stuff from those folders into the matching folders inside of your CUDA installation. So you can see here inside of CUDA, we've got a bin folder, we've got an include folder, and we've got a lib folder. So what we first up need to do is grab all the stuff from the CUDA or from the CUDNN folder, open up the bin folder, grab all of that, paste it into the bin folder inside of our CUDA installation. So paste those there. You can see it's going to copy over. It'll probably ask for admin privileges, maybe. Who knows? We'll see. You can see it's got privileges. We can hit continue. All right, so you can see that I've copied it from here over to here. So we've copied it from the CUDNN zipped folder or wherever we've gone and downloaded a folder. So that particular repository, we're throwing it into where we've got CUDA installed. And we need to do this for all of the different folders. So inside of CUDNN, we also need to go into include, copy all of this. And we are going to put it inside of our include folder from where we've got CUDA installed. So open it up, include. We're going to paste it in there, hit continue. Right, so you can see I've copied it from over to here to here. Then the last one that we need to do is the lib folder. So inside of lib, you've got a subfolder, so x86 or x64, my bad. We're going to copy these over. We're going to go into lib, x64, paste those in there. Hit continue. Booyah. That's pretty much CUDA and CUDNN now installed. So we can actually mark this as done. Actually, wait, no, I lie. We actually have to do one more bit. We have to update our path variable. So let's go and do that. Ooh, lucky save, Nick. Okay, so let's go ahead and do that. So we've gone and done all of our copies so that we can close that. We can close that. We also need to add, let's mark these as done. So that's done. That's done. Grab a drink of water, got to hydrate. We now need to add our GPU or our CUDA installation to our path variable. So these three lines need to be added to the path. So C program files or wherever you've got CUDA installed. So this is the CUDA installation that I've got. So C program files, NVIDIA GPU Computing Toolkit, /CUDA, /11.2. So if your version changes, so let's say, for example, goes to 11.3, more often than not, you're going to be putting in 11.3 here. In our particular case, it's 11.2. So we need to include the bin folder, the libvvp folder, and the lib64 from cupti. So we need to include those three inside of our environment variables. So for Windows, you just need to go environment, edit the system environment variables, and then go to environment variables here. And what we need to do is add these to our path. So if you select path, open that up. Looks like I've already got them in there. Let's actually delete those, delete. So all you need to do is hit new and then paste each one of those in. So I'm going to copy that. I'm going to paste it in there. I'm going to copy that. Paste that in there. Delete the spaces. And I'm going to copy that and paste it in there. Let's make sure there's no spaces at the start. Hit OK. Okay. That is CUDA successfully installed. But what we want to do is we want to go and validate this. So let's just hit that as done. Let's go and validate that this is actually working now. Now, right now, if we went and open this up inside of our Jupyter notebook, it wouldn't necessarily pick up because we don't necessarily know if it's picked up the new environment variables. But you can see here that we've actually got errors. It's saying cannot open, CUDNN 64_8. That's because we haven't actually installed that, or we hadn't installed that when we went and ran TensorFlow. So what we can actually do is we can stop all of this and let's start up our Jupyter notebook again. How do we do that? Pop quiz, guys. Give you 2 minutes 2 seconds thinking time. Dun, dun, dun. All right, no, never mind. Again, Jupyter Lab. Coolio. So, all right, open this over here. All right, cross your fingers, guys. So again, this is our same Jupyter notebook. We don't need to go and rerun the installs. What we can do is now import TensorFlow. And fingers crossed, if we go and run this next line, you can see our GPU is showing up there. Key thing to note that you do need an NVIDIA GPU. That is the core thing. So they are working on GPU acceleration support for TensorFlow for AMD GPUs, but it's really just not there yet, at least at this stage. So in 2022 right now, at the start of 2022, it's really not there yet. It might be getting there towards later this year or towards next year, but for now, just know it's not there as of yet. But this tells us that our GPU is now successfully working. So we can now mark this line as done. Let's jump back on over to our client and see what's last.
So it looks like the GPU is registered, right? Right, let's actually walk through this deep learning project. It's something that I've pre-written that allows you to build an image classifier using convolutional neural network layers and any image data. Nice. So it can tell me what any image is? Well, kinda. It'll be able to classify an image as belonging to a specific class or not. We'll take a bird's eye view of it, and maybe in a future tutorial we'll do a deep dive. Okay, cool, let's roll.
Alrighty, and we're back. So we have one last thing to do. So we need to train an image classifier for any image. But for now, let's take a look at what we've done. So we've gone and installed Python and Jupyter with Anaconda. So that's done. I've gone and shown you how to create a custom environment and attach it to Jupyter. We've taken a look at how to install TensorFlow for deep learning. And remember that it took 692 milliseconds per step without GPU acceleration. We then went and installed CUDA and CUDNN, and I showed you how to find the correct versions. Keep that in mind, guys. You need those correct versions. Last thing is we are going to go and train our image classifier. Now, again, this isn't going to be a full deep learning tutorial. The core crux of this tutorial is to get you up and running. We're going to go through the full image classification tutorial in a couple of days' time, or when I finally release that video, but it is coming. So the beauty of the pipeline that I'm about to show you is that you can literally download a bunch of images from the web and build an image classifier from it. And that's exactly what I've done. So let's actually take a look at our notebook. So remember, at the first lines that we ran in our notebook were the installation. So we ran pip install TensorFlow, TensorFlow-GPU, OpenCV-Python, and Matplotlib. We then also ran pip list so we could see what versions of stuff we've got running. We also went and ran some imports. So import TensorFlow as TF. So this allows us to use TensorFlow, and import OS. So that allows us to navigate through our operating system. This is some pretty standard code. So by default, TensorFlow is going to expand to use all of your virtual RAM. So if I actually show you this. So inside a task manager, if I go to performance and go to my GPU, so right now it isn't fully utilized. So as soon as we go and create a TensorFlow model, it's going to take up virtually all of that. and it will try to take up more if we didn't have this set. So this is going to help you avoid out of memory errors. This is just a test, so it's telling us whether or not we've got a GPU available. So you can see that before we had CUDA installed, that wasn't popping up. Once we installed CUDA, that is now available. Now, when I was downloading images from the web, I noticed that there were some dodgy file types that weren't necessarily working. So these 3 blocks here, or 4 blocks, allow us to get rid of those. So I can actually run through these, and it's going to check whether or not the image is a valid JPEG, .jpg, .bmp, or .png file, and that is going to allow us to load that into our TensorFlow dataset. Now, this is exactly what we're doing here, but again, we're going to go into this in way more detail once we go through the full-blown image classification tutorial, which is going to be coming up, and that will be for beginners, right? Okay, so what we can then do is load up our data. So this line here, so tf.keras.utils.image dataset from directory, allows us to pull in our image data from our data folder. So if we go and take a look at our data folder, so D, where were we? Image classification data. So we've got 2 folders there, happy, and these are just a bunch of happy images that are pulled from the web. And we all, where are we going? And we've also got a folder called sad. Again, a bunch of sad people from the web. Coolio. So we can go and run that line, and that is going to load up our data set. What we're actually doing here is we're actually working with the TensorFlow data loader. So if you take a look at TensorFlow data sets. No, that's not what I'm looking at. I want tf.data.dataset. Oh, another really, really important tip, guys, is if you want to look at documentation for a particular line of code, write the line of code and then type in question mark. It's going to open up the documentation for that. How sick is that? So what we're actually using in this is the TensorFlow dataset API. So this just makes it a whole lot more efficient when you're training deep learning models. But again, I'm going to go into this into way more detail. So we are using the helper, which actually creates an image dataset. So it creates or loads up the images or creates an image pipeline, and it also creates a set of classes. So here we've got 2 different classes. We've got happy people and sad people. So happy people are assigned class 0, so you can see that there. Sad people are assigned class 1. We can then run it through our data pipeline. So this pipeline scales our data. So we actually divide it by 255. The reason that we do this is neural networks perform well with data which is between 0 and 1 or -1 and 1. So the smaller the data, the faster your model is going to be able to train. So that's why we scale. So this is effectively performing that scaling there. We can then split it into a training, validation, and testing partition. Boom. And then we can build our deep learning model. So here we are using the TensorFlow sequential API. There's 2 key TensorFlow APIs or Keras APIs, the sequential API and the functional API. Sequential is really, really good if you've just got a quick model that you need a prototype and you've got a single input, single output. If you've got a whole bunch of custom stuff or you've got multi inputs and multi outputs, then typically you're going to be using the functional API. The functional API is available through this. So from tensorflow.keras.models import model. That is the functional one. This is the sequential one. So again, we can run that. So we're going to be using the sequential one for this model. So we can create an instance. And then this is adding all of our layers to our deep neural network. So you can see here that we have some CNN layers or convolutional neural network layers. And then we follow that by a bunch of max pooling layers. So this is affectionately called a block. So we've got 2 blocks and we're repeating them. So 1 block, 2 blocks, 3 blocks. We then flatten it down and we are going to be outputting a single value and we are going to be activating that with a sigmoid function. Again, you don't need to worry about what this actually means. Just know that we're taking in our images as an input, and what we're going to get out of it is whether or not that particular image is a 0 or a 1. That's what this neural network does for us. So if we run this, we can then compile this model, and this allows us to assign an optimizer and a target loss function to our model. So here our optimizer is an atom optimizer. There's a bunch of them. Again, we'll go into that into more detail later on. And we are going to be using binary cross entropy, which is the appropriate loss function for a binary classification model. So we can run that. And this gives us a summary of what our neural network looks like and tells us that our neural network has 3.7 million parameters. So pretty big, but again, it could get way bigger. I was using one that was 97 million parameters just yesterday. Then we can go on ahead and train our model. So again, we can run these 3 lines, and again, Shift Enter allows you to run a couple of lines. You can also run Control Shift, I think it's Control Enter, which stays on that cell. Shift Enter goes to the next cell. Now remember that our neural network prior to actually having our GPU took, what was it? 692 milliseconds per step. With a GPU, it's running at 257 milliseconds per step. So less than half the time. So this means that having a GPU is going to save you a ton of time, particularly when you got massive models. This is only a small model, so you're only seeing a partial improvement, even though it's more than 50% faster. So again, way, way faster. But pretty cool, right? And over here, you can track how well our model is performing. So we have, it started out at 54.91% accuracy, and it is getting up to 99, almost 100%. So again, performing way better. And it's actually telling us our accuracy on our training partition as well as our validation partition. We do that to help ensure that our model is not overfitting. All right, so that is our model finished training. So again, it went really, really fast with the GPU. And we can actually take a look at how it's performed. So if we run this line, you can see that over time, so the green line is on our training data, the yellow line is on our validation data. So if you start to see these diverging, it might be an indication that you have, a variance problem. So again, you might need to use regularization techniques to ensure that your model does not overfit. So that's our loss, and our loss is our binary cross entropy, and then this is our accuracy. So again, I know I'm glossing over a lot of these components, but we're going to dive into this in way more detail when we actually do the image classification tutorial. So that's what our accuracy looks like, and again, they're sort of following together, so we're looking pretty good. We can then go and evaluate on our testing partition. So here we're going to calculate precision, recall, and binary accuracy. If we go and run this, looks like we've got 100% for, precision, 100% for recall, and 100% for binary accuracy. So again, performing really, really well. We can then go and test it using OpenCV. So use OpenCV to read in our data. And we can then go and resize it and go and make a prediction. So over here, you can see we're running model.predict. So there's two key things to your model. So model.fit, which trains your model, and model.predict, which actually allows you to make a prediction. So if we go and run these, have we run that line already? Yep, we have. If we go and run that line, we haven't run that. Key thing to note is that when you go and run your Jupyter Notebook for the first time, if you haven't run it before, these values are going to be 0 over here. But if you've run it previously, saved it, and then reopen it, it will still show these values. So we can go to here and run, let's not run it. I'll actually go through it more in the object or the image classification tutorial. But just know that if you see a value over here, it means it's been run at some time previously. If you go and clear that output, run it again, you can see that that is now available. If I clear it, again, go to edit, go to clear output, there's no number in there. If I go and run this, we now have a value. So if we go and run the predict function, it is predicting a 95%, which is closer to, what are we getting up here? So closer to our SAD class. So ideally, we've got a SAD image there. Do we have a SAD image? We don't have a SAD image. Is that predicting SAD? It's predicting SAD. So it doesn't actually perform that well. Let's go and test it out with another image. So data, we'll go and grab this one over here. So this one is a SAD image. Let's go and run this. So that is predicting SAD. So this might be an indication that it is overfitting. Let's actually test it out on another image. So if we go into our data folder, happy, let's go and grab, this dude. And if we paste it over here, grab the name of that file. So it's 05-12-21, happy people. Paste that over here. So that's our happy person. That is predicting happy. So you can see it's closer to 0, right? Happy. That is one of the problems that we might need to fix up in our image classification tutorial. So how to evaluate whether or not your model is actually performing well. But in that particular case, you can see we are generating predictions from our model using a deep neural network. What we can then do is save down our model using the model.save function over here. So now we have a file called imageclassifier.h5. Let's actually call it new version live. So if we go and save that now, my bottle's blocking my, so if we go to image classification, my bottle's blocking the, the taskbar. So if we go into models, you can see that we've now gone and saved down that new version. So image classifier, new version live. And if we want to go and reload that, so if you're going and building up I don't know, like an API or something, you'd want to reload that into memory. So to do that, we can use the load model function. Go and paste that in there. Boom, we've reloaded it, making new predictions. So I know I went through that really, really quick, but I wanted to show you how to set up your pipeline, how to get things up and running, and at least test this out. But we are going to go through the image classification tutorial in way more detail in a tutorial coming up. So you'll actually see how to do this properly, how to grab new data, how to add new classes, so on and so forth. But in a nutshell, know that you need to install your dependencies, clean it up, load your data, do any pre-processing, and then build your deep learning model and take a look, evaluate it, and then actually test it out. But that in a nutshell is how to get up and running with deep learning. Again, stay tuned. We've got some more stuff coming. Thanks again for tuning in, guys. Peace.
Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a big thumbs up, hit subscribe, and tick that bell, and let me know what you thought of this. We are getting very much back into deep learning tutorials and really doing stuff from scratch. Like, how do you stack layers? How do you build really specific use cases? Let me know if there's any specific ones that you'd like to see, or any specific deep learning use cases that you've seen floating around the web that you find interesting. Thanks again for tuning in, guys. Peace.